So the final video in this series is on which formula should I use. So you're not always told which formula you should be using, and you need to look at the information of what you have, and that will tell you which rule you should use. So if you have a side and the angle opposite the side, then you're going to use the sine rule, with the side over the sine of that opposite side to work out a missing side, and inverted to work out a missing angle. If you have two sides and the included angle, and you're wanting to work out a missing side, then you're going to use the cosine rule, which is a squared equals b squared plus c squared minus 2bc times the cosine of the angle. If you've got all three sides and you're looking for a missing angle, then you're going to use the cosine rule in the form the cosine of a equals b squared plus c squared minus a squared all over 2bc. And if you're asked to work out the area of a non-right angle triangle and you've got two sides and the included angle, then you're going to use the formula a equals a half multiplied by ab sine of c. So in the first example, we want to find angle x degrees. So you can see that we've got a side and the angle opposite the side, and we've got another side and angle opposite the side. So therefore, we're going to use our sine rule, and because we want to find angle x degrees, we want to use the sine rule for a missing angle. So that means we're going to invert our sine rule from the way that it is on our Nat5 formula sheet. So the sine of angle A over side A equals the sine of angle B over side B. And we want to annotate our diagram. Angle A is going to be the x degrees, and then we can write on our other letters so that we can substitute those values in. So we've got sine of x degrees over 11.3 is going to equal the sine of 36 degrees over 9.2. Now we're going to multiply both sides by 11.3, and we get sine x equals 11.3 times sine 36 over 9.2. And using our scientific calculator, x is going to equal arc sine, or the shift sine button, of 11.3 sine 36 over 9.2 using our fraction button, and that's going to give us a value of 46.2 and so on, and rounding it to the nearest degree is going to give us a size of angle x of 46 degrees. So in the next example, we want to find the length of x, so this time we're looking for a missing side. And going to our diagram, you can see that we've got two sides and the included angle. So we're going to use the cosine rule for a missing side. And our cosine rule for a missing side is a squared equals b squared plus c squared minus 2bc cos of angle A. So going back to our diagram, we've got side A is x and angle A is 102, and B and C are the 9 and 12 centimeters. So a squared equals 9 squared plus 12 squared minus 2 multiplied by 9 multiplied by 12 multiplied by the cosine of 102 degrees. That gives us a value for a squared of 269.908 and so on. And if we square root that using our answer button on our calculator, then the length of x is going to be 16.428 and so on, and rounded to the nearest centimetre, x is going to be 16 centimetres. In the next example, we want to find the length of y. So this time it's a missing side, and you can see that we've got a side opposite an angle, and we've got two pairs, so we can use our sine rule, and this time it's a sine rule for a missing side. And this can be written as a over the sine of angle A equals b over the sine of angle B. And going to our diagram, we're going to mark on a as y, and angle A is 42, b is 13, and angle B is 52, and substitute those in. Y over sine of 42 is going to equal 13 over the sine of 52. We're going to multiply both sides to get rid of that sine 42. So 13 sine 42 all over sine 52. And that gives us a value of y of 11.038. And if we round that to the nearest centimetre, we're getting 11 centimetres for the length of y. So this example, we want to find the area of this triangle. And so we know that the area formula for a non-right angled triangle is A equals a half of AB multiplied by the sine of the angle C, where C is the included angle, so it's the angle between A and B. So it's the angle between the 11 metre and 90 metre sides. And we can determine what angle C is going to be by using our knowledge of the angles in a triangle. And so 180 take away the sum of 61 plus 43 gives us an angle C of 76 degrees. So now we can mark that as angle C in our sides A and B and substitute those values into our formula. So we've got a half multiplied by 11 multiplied by 19 multiplied by the sine of 76 degrees. And that's going to give us an area of 101.395 and so on. And rounding that to one decimal place gives us an area of this triangle of 101.4 squared meters. Now our final example, we want to find angle x degrees. And you can see this time we've been given 3 sides and we want to work out a missing angle. So that means we're going to use the cosine rule for a missing angle. And from our Nat5 formula sheet, we know that this is the cosine of A equals B squared plus C squared minus A squared all over 2BC. So our x degrees is our angle A, and the side opposite is 5.4, so that's side A. Doesn't matter what B and C are. And we can substitute that in, so the cos of x degrees equals 11.7 squared plus 15.2 squared, take away 5.4 squared, and that's all over 2 multiplied by 11.7 multiplied by 15.2. And that gives us a cos x degrees of 1783 over 1872. Now to work out what angle x is, we're going to do the arc cosine of that fraction. So x degrees is going to be arc cos, or the shift cos button, of 1783 over 1872. And that's going to give us an angle x degrees of 17.738 and so on. And rounding it to one decimal place gives us an angle x degrees of 17.7 degrees.